All right, good morning everybody. Thanks for coming out so early. My name is Rowan Miller. I'm a program manager and I work on the Entity Framework team at Microsoft. And this morning we're talking about Entity Framework 7. I just wanted to take a second to set some expectations for this session. First of all, this is listed as a level 300 session, so what you're not going to get in here is a 101 introduction to Entity Framework. We're going to be spending most of our time digging into code in Visual Studio, looking at how things work. Now, this might be obvious from the title, but this is also a session on Entity Framework 7, so this isn't going to be a session on how to use the current stable releases of Entity Framework that are available today. This is going to be a look ahead at what's coming up in the future in Entity Framework 7. I guess another thing to point out too, you're going to get the most out of this session if you have previously used Entity Framework. So hopefully the content will make sense to you and be useful if you haven't, but most of it's going to be a look ahead at how EF7 differs from previous releases, and so you're going to get the most out of it if you've used Entity Framework before. So our agenda is extremely simple. We're going to spend a few minutes talking about what EF7 is. This is the slide section of the talk. How many people in the room have sat in an EF7 session before or watched something online or have some idea what EF7 is about? Not very many people. Okay, so for the few of you that have, the slide section lasts for about 5 minutes and it's content you may have seen before, and then we're going to switch into demos for the bulk of the talk. Now the demos are mostly new. You may have seen one or two of them in other sessions before, but for the most part this is fresh content put together for Ignite. And then at the end, I'm going to leave you with some next steps if you want to spend some more time digging into Entity Framework 7. All right, so let's quickly talk about what EF7 is. Our tagline for EF7 is it's all about new platforms and new data stores. So double-clicking on that and seeing what that actually means, historically, Entity Framework could only be used when you targeted the full .NET framework. So this was like .NET 4 or .NET 4.5. But in EF7, we're opening up support for additional platforms as well. So when you target ASP.NET 5, you can target either the full .NET framework or the new .NET Core. And so Entity Framework 7 can be used in both of those scenarios. Windows 10 Universal Application Platform also runs on .NET Core. So EF7 will work there, which will allow you to write applications that target desktop, tablet, and device. And then in addition to that, you'll also be able to use EF7 when you write .NET code that's going to run on Mac and Linux. Now this is both Mono, which is effectively the full .NET framework, or the new cross-platform .NET Core that the .NET team is working on. The point of this slide is we want anywhere that you would write .NET code and anywhere that you would run .NET code, we want you to be able to take advantage of the coding patterns that you're used to, including Entity Framework. So new data stores. Historically, EF just supported relational data stores. The concepts of a relational database were baked right throughout the stack for Entity Framework 6 and earlier releases. But in EF7, we're opening up support for non-relational data stores as well. Now, I want to be really clear. What we're not doing here is trying to build a magic framework that hides the type of data store you're targeting. Frameworks like that demo really well on stage, but when it comes time to write an application, they tend to fall down very quickly. So what we're talking about when we target relational and non-relational data stores is the common components that make sense across all data stores, or most data stores, like having something that can take a link query and translate it into store-specific query syntax, having a context that tracks changes to your objects and then passes them off to the data store to persist. Those things are baked into the core of EF, and then the non-common components are parts of providers or parts of classes of providers. So for example, if you target something like Azure Table Storage, you need to configure row and partition keys for your entities. Those methods come in as extension methods when you target the Azure Table Storage provider. If you're targeting a relational database, then you care about things like table and column mapping. You care about the cascade delete behavior on relationships. And so all the APIs to do that come in when you target a relational provider. And just to give you some examples of the kind of things we've been working on, obviously, we've been working on relational providers. So we've shipped the SQL Server provider in our previews, and then not quite shipping in previews yet, but working offline. We're also working on a SQLite provider. We've been working with the folks that run the NPG SQL project to have a Postgres provider, and then one of our MVPs is also working on a SQL Compact provider at the moment. And then our team has also prototyped Azure Table Storage and Redis providers. Now again, these aren't included in our public previews at the moment, but we're doing prototyping on them to kind of prove that the architecture we're building for EF7 works for non-relational data stores as well. We do intend to eventually RTM those, they're just not included in the current previews at the moment. And then finally, we've also been working on an in-memory data store. Now, the intention of this data store is to give you an easy way to swap out a real database for something fake when you want to run tests, something that was quite difficult to do in past versions. So that's the high-level vision for EF7, but there's some other changes coming as well. So one of the things we're doing is kind of reimagining or overhauling the core of Entity Framework to build something that's new and lightweight and extensible. So those are good buzzwords, but let's talk about this new core coming in EF7. Most importantly, it's the EF that you're used to. So we're not building a completely new data stack. You still derive from DB context. You still create, or you expose DB sets for every type in your model. We still have a set of conventions that run over your classes and build a model based on them. It's the same conventions that were there in EF6. If you want to supplement those conventions, you still override the on-model creating method and write code to supplement them. Under the covers, though, EF7 is going to have a very different core. Now, when we talk about core, we're talking about things like the object model that stores the metadata for your model. We're talking about the underlying components that keep track of the changes to your entities as you manipulate them in memory. Now, to be clear, when we talk about something like change tracking, the underlying components change. The top-level API, so if you use dbcontext.changeTracker API, that remains more or less unchanged in EF7. It's the underlying components under the covers that are different. So there's a lot of benefit in this. You can think, has anyone used the metadata API from current versions of Entity Framework? Like metadata workspace would be the API. If you have, I'm sorry, it's a really horrible API and it's very difficult to use. The new API coming in EF7 will be much more usable, much more intuitive. Now, of course, this means if you have applications that target those lower-level components, there will be some code changes to make them work. But we think it's time to make the change. So a couple of other points to make here too. Having this new kind of extensible, neatly factored core makes it easier to extend and replace components. Now, this could be something you do. It also makes it easier for third-party frameworks to plug in components. So a good example of this would be something like Glimpse, which is a logging and diagnostics framework for ASP.NET. They had a really hard time plugging into Entity Framework 6. In EF7, it's much easier for them to get access to the logging and diagnostic information they need. And so this will make it much easier for third-party tools to come out to help you to build an ecosystem of things that help you write apps with Entity Framework. I mentioned the metadata API. We had a whole bunch of APIs that kind of had confusing behavior and confusing API patterns, so we get a chance to reinvent some of those. Obviously, we're optimizing for memory and CPU usage. Now, we've been making good gains here in EF6, but in EF7, especially as we look at running on devices and running in the cloud, where in the cloud you pay for the resources you use, then really nailing down and using less memory and less CPU is good because it means your apps run faster on devices, and it means you pay less when you host them in the cloud. And then finally, one other concept I wanted to mention that we're using in EF7 is pay-per-play. So if you're targeting, say, Azure Table Storage, in EF7 things are factored so that you won't even get the relational components referenced in your project, let alone loaded into memory. And so we're really trying to say you should only even reference the components of EF that you're actually going to use. Now, this is different from EF6. If you installed the Entity Framework 6 package, not only did you get all the relational components, but you actually got the SQL Server provider nicely included for you by default, which is great if you're targeting SQL Server, but it means you've got this extra assembly that you're referencing and loading up into memory all the time, even if you're targeting a different database. Now, another advantage of a new core is we actually get to add some new features easily. I've listed a few of them here. I'm not going to go over them now, but these are features that were extremely difficult for us to implement on the previous versions of Entity Framework. The core just was factored in a way that these particular features would have taken a very long time to implement, and they would have been extremely difficult to test and stabilize. But now, with a new core purpose-built for the direction we're trying to take Entity Framework, we can bake these features into the first version of EF7. All right, that's enough of slides. Let's dig into some demos and see what we're actually talking about. Now, before we actually start writing code, I want to introduce you to the company we're going to be working with. We're working with an online retailer called Unicorn Store. So as you might expect, this is a standard online store. I can browse around, and they have an interesting collection of unicorn wares. They're a little bit light on inventory at the moment. Now, this public-facing website happens to be an ASP.NET 5 application. So if I swap out to Visual Studio, we'll see the Unicorn Store solution here. You'll notice that we have, under References, we have entityframework.SQL Server reference here. So this is a NuGet package. So we're targeting the SQL Server provider for Entity Framework. I happen to have two models in this application. I have the ASP.NET Identity model. So I'm using ASP.NET Identity for logins. I've extended this model. So I'm capturing things like addresses for users. And so that's one of the EF models. And then the second one I've got is the Unicorn Store model. And this has things like the product class in it, the categories that those products belong to, the items sitting in a user shopping cart, the orders they've placed, the shipping details for those orders, all the stuff we'd expect for an online store. And just to prove that it looks the same as past versions of Entity Framework, here's my context. You'll see that it inherits from DB context. I'm exposing a DB set for each type in my model. And then I have an on-model creating method where I perform by extra configuration. Okay, so that's a quick lap around the application. Let's start using this application to explore some of the features of Entity Framework 7. Now, the first thing I want to do, this first section of demos is done using the currently available Beta 4 of Entity Framework 7. Later in the session, we're going to have some demos that use some private internal builds, and so I'm going to call out when I get to the stuff that you can't do yourself at home. But this first section, you can download the bits off NuGet.org today and actually try it out. Now, it's not the most interesting and fancy demo to start with, but the next few demos we do after this are going to be reliant on us being able to see all the SQL that's sent to the database as we use Entity Framework. And so to do that, we want to implement logging. So let's take a look at logging in Entity Framework 7. Now, I want to call out for this demo that I'm going to be using the kind of low-level components that make up logging in EF7. We haven't done it yet, but we are going to build a higher-level experience that makes it very easy for you just to get access to the raw SQL commands being sent to the database. But I'm going to hook in much lower in the stack and get to all of the logging information and then select the pieces that I'm interested in. Now, you don't want to watch me write a whole bunch of code on stage, so I've made a start on the logging implementation. At the heart of logging in Entity Framework 7 is this iLogger interface. Now, one thing that's important here is iLogger is not specific to Entity Framework. It comes from the Microsoft.framework.logging package. And it's used by Entity Framework 7. It's used by ASP.NET 5 and all the components that make that up, like ASP.NET Identity, the actual core of ASP.NET 5, MVC, and then hopefully used by other frameworks in the future too. At the heart of iLogger is this log method. Now, log doesn't just take in a string, so it's not just about human-readable things. You'll notice it takes in some state. So in here, some of the logging will pass in DTOs that contain strongly typed information. So you can imagine with a SQL command, I might give you a DTO that has the actual SQL command, the values for the parameters, maybe the database that it's targeting. If we happen to be logging an error, then we'll give you the exception. So this could be useful if I wanted to write a custom logger that does something special when a SQL exception is encountered. I could check if the exception's a SQL exception and then do some special logic there. And then finally, with logging, a lot of the time I do want some human-readable text. So the last thing we give you is a func called formatter, which accepts the state and the exception and will give you back a human-readable string. So for our scenario, we basically just want to run the formatter, which you can see I'm doing here. I'm passing it into string format just to include the date and time that the command was run, just so we can see the order things are happening in. And then you'll see I'm appending all of that text to a file, which happens to be sitting in my temp directory. Now, there's actually a layer of abstraction above iLogger. There's the concept of a logging provider. So what happens is each component in the stack actually asks the logging provider for the logger that it should use. So this gives me the opportunity to return a different logger to different components in the stack. Now, I've got a list here of the two components that we're interested in, the batch executor and the query context factory. In the context of a relational data store, are the two components that actually generate raw SQL commands. So when I'm asked to create a logger, I'm given a name, and that name happens to be the fully qualified name of the component requesting the logger. So I'm just going to write some logic here to say if the components list that we're interested in contains the name of the component requesting the logger, then we're going to return a new instance of our SQL logger. If not, we'll just return a null logger, which is a logger that does nothing. The logging goes nowhere. All right, now I could go and just register this logger directly with Entity Framework, but I'm operating in the context of ASP.NET 5. And ASP.NET 5 has dependency injection baked in at its core. So if I go down to startup.cs, we'll see a whole bunch of code here where all the services are getting registered with the dependency injection container. And in fact, you'll see here that our contexts are getting registered in the DI container too. So for folks that aren't familiar with dependency injection, it's basically just a container where I register all my services, and then the components in my application, like my MVC controllers, can say, I depend on having a unicorn store context. And the dependency injection container takes care of creating an instance of that context and giving it to my controller. Now, the other neat thing is that services in the container can also depend on other services in the container. So because my contexts are in the container, we're going to register our logger, and then the context will automatically flow the logger into it. So I'll scroll down. You'll notice we have a line of code here where we're adding a console logger. So if I run from the command line, I'll automatically get a whole bunch of logging out to the command line. And I can have multiple providers registered. So I'm going to go ahead and add in our provider as well. And then let's run our application. Wait for the app to boot up, and then I'm just going to browse around a bit so we do some interaction with the database. And then we'll go open up the database.log file from disk. And let's give it a bit of syntax highlighting. And so we see all of our interactions with the database being written out to a file. Now, if anyone's profiled the commands sent to the database in previous versions, you'll notice that the stuff we're writing out here is a lot cleaner than what we've historically generated. In past versions of EF, we would pretty much always wrap everything in a nested select statement. But now you can see this literally looks like something I would actually write by hand if I was going to query the category table. So we're trying to make the very simple cases of queries look very simple, like you would write them by hand. All right, now that we have logging, let's dig into some of the improvements we've made to SQL generation. You just saw that simple queries look better, but we've made some other improvements too. So one area of functionality we have on the website is this search box. But you'll see at the moment, if I go ahead and search for something like shirt, search functionality is not implemented. So let's drop out to Visual Studio. We'll go to our controllers and load up the shop controller. And we'll see that there's a search action on here which accepts the search term, and at the moment it's not actually doing anything to load the appropriate products from the database. Now what I could do here is start writing a link query, and I could say where, and I could check if the name of the product contains a term and if the description, and maybe I want to go and look at the photos of the product and see if any of the captions contain the term. But that's not going to be the most efficient way to do this. Probably the best way to do this is to make use of a feature in my database, maybe full text search or some other indexing capability of whatever data store I happen to be targeting. And actually, if we go and look at the database, I've already done that. You'll see I have a table-valued function here called search products. It accepts a search term in, and then it has the result set that matches the columns from the product table. So we can do something similar to what we could do in past versions of Entity Framework, and we can just execute some raw SQL for this particular query. So we're going to say select star from our table value parameter. We want to pull. We obviously don't want to just inline the search term, so we're going to use parameterization. EF's nice because it allows me to just pass in the actual object, and it will take care of wrapping it in a parameter for me. Yes, that is not going to work. Thank you. All right, let's go ahead and run, just double check this works. Don't worry, this isn't the extent of my demo because you could do this in past versions of EF. So we'll just make sure this bit's working. All right, so now we're getting the shirts back. But they're just coming back in whatever order they happen to get streamed from the database. Maybe I want to order them so that the item the user is most likely to buy is the first item listed. So maybe I want to order by the current price. Now, historically, what we would have done in Entity Framework is I've opted into SQL, so I would have had to go and add an order by here. But wouldn't it be nice if I could just start composing on top of this using LINQ? So we're just going to say order by the current price. We'll run the application again. We'll again search for shirt. We'll see that things are now ordered by the current price. And if I drop out and look at the log here, you'll see that I have my raw SQL in the middle there, and it's wrapped in a select, and I have the order by nicely inlined there. All right, so ordering by the price is interesting, but just because an item's cheaper doesn't mean it's the best deal. Maybe I want to order by the savings. And so you'll see here I have an item here that's $19.95, but it's actually $5 off, as opposed to the one that's listed first at $2 off. So rather than ordering by current price, I want to order by the savings. Now I could do some math in here and say order by the MSRP minus the current price. But the concept of calculating the savings for a product is something I'm going to want to do over and over again. Now, it's not really data I want to store in the database because it's a very simple calculation that can just be done in memory based on the data in the object. So let's go and open up the product object. And let's add a helper property. We'll add a decimal property called savings. It's just going to have a getter. And we're going to return MSRP minus the current price. And then if we go back to our controller, we probably want to order by savings, and we probably want to make that descending. Now, historically, in past versions of EF, this would not have run because our query pipeline in the past insisted on translating the entire query into SQL. It would never do anything in memory. And the problem with that is Entity Framework has no idea how to translate this property into a SQL statement because the implementation of that property, the logic in there, is completely opaque to Entity Framework. But let's go and run the application. We'll once again search for the shirts, and we'll see that this query actually runs. So we can now include fragments of our query that are going to evaluate on the client. Now, obviously, this is something you need to be a little bit careful with because doing something like an order by is fine in memory. But if I'm doing something like a filter where I'm trimming a list of 10,000 entities down to 5, then that's not something I want to run on the client. And we're still playing around with the right safeguards and switches to give you to enable and disable and warn when excessive amounts of client evaluation happen. All right. Yes, question? The question was, does that change the SQL at all? So let's go look at the SQL. So the SQL at the moment, it still has my original SQL I put here. Now, in Beta 4, we actually still always wrap your original SQL in a select statement like this, which is fine, but it doesn't look that pretty. So what we're actually working on at the moment, post Beta 4, is if you don't compose on top of your statement, then we shouldn't do the nested select at all. We should just let your actual raw SQL flow straight through. But for the moment, we do always wrap it. And so the order by now isn't pushed to the database. It's done completely in client evaluation. All right, so another area of our application that we're going to look at, if I go and look at the orders that I've placed, we'll see that we have my 2 orders that I've historically placed, and then I have some logic in my view to display the order lines, the actual products that I ordered, but at the moment that data is missing from the view. So I'm going to go to the action on my orders controller. This would be the index action. And you'll see we're pulling back orders, but we're not including any code to include the order lines or the associated products. Now, as with past versions of Entity Framework, I can go ahead and say include, and we want to include orders.lines. Now, in past versions, for each of those lines, I probably also want to include the associated product. The syntax in previous versions was pretty nasty and hard to discover because I would have had to say select products, and nobody would work this out just from playing around with the API. What we're doing in EF7 is introducing a new API where I can then just start composing on this and say then include. And I can say line dot, oh yeah, for some reason IntelliSense doesn't work for me here, but it will compile. And then I can keep going on this too, so I could say once I've included the product, then go and include something else based on the product. And if I want to drop back out to the top level, then I can just say include, and then I will start including again based on the original order that I'm querying. So let's run this and just make sure it works. Okay, so we see the data is now coming back. Now, interestingly, if we think about the shape of this query, I asked for orders. I wanted to include the order lines, and then in turn, I wanted to include the product. In past versions of EF, we would have joined that all together into one big SQL statement with two left outer joins in it. Now, what's interesting there, if you can picture this, is I would have all the order data for the first line, the first order, and then I'm going to have each of the lines in the result set, but I'm going to go ahead and replicate the order data for every order line. So this gets to be very inefficient because we're dragging way more data back from the database than we need to. What we've started doing in EF7 is when you include a collection, we actually split it up into a separate SQL statement. And so if we look at what we've got here, we'll see the last two statements refer to that single query that I ran. We're selecting here from the orders, and we have our filter that we applied there. And then on the second line, we have a second result set, which is pulling back all of the order lines. You'll see we still join to the original table so that we can run the same filters. And then because the order line joins to a single product, so it's not going to be like a cross-multiplication problem, it's just going to be one product for one order line, then we do that join in line rather than running a second statement. So the nice thing now is we've kind of freed up the contract between Entity Framework and the providers, so the providers have a lot more flexibility to say, on this data store, this is the query that makes the most sense to run. You can imagine, too, if you're running against a non-relational data store and you want to do some joining based on data, then there's not going to be the concept of an inner join. You're always going to be running separate queries. But on SQL, we can choose what makes the most sense as a separate query or result set and what makes the most sense as a join. All right, one final piece I want to look at for SQL improvements. I'm logged in as administrator here, which means I have the ability to manage the products in the store. Then we also have this new piece of functionality where an administrator can come in and say, I want to give a discount over this whole category in the store. So we want to give a 50% discount on kitchen and dining. Now, if I run this at the moment, you can see it doesn't actually work. The current price and MSRP are still the same. So going back to Visual Studio, we'll look at the Manage Products controller, and we're going to go to the bulk price reduction action. And so you'll see here we're loading all the products from that category. We're then looping through each of the products. We're calculating the discount. We then need to add some code to say the current price is equal to the MSRP minus the discount. So we're going to loop through and do that for each product, and then at the end we're going to go ahead and call save changes. Let's run this again. So I'm going to go ahead and pick on kitchen and dining again. Apparently our unicorn coffee mugs aren't selling so great, so we're going to give a 50% discount. So you can see this time around that the prices are updated to 50%. Now, just to think about what happened here, we loaded up, in this case, 4 products from the database. We manipulated the current price, and then we went ahead and called save changes. In EF6, this would have resulted in 4 round trips to the database, 1 for each row being updated. But in EF7, you can see we batch everything up into a single statement here. So instead of multiple round trips, I get a nice batch with everything included in it. Now, you look at this and you think, well, for updates, that's pretty easy because you can just literally append the text to the end of them. But what about inserts and things like that? So we're actually quite smart in how we do this. If I was to say go ahead and insert 100 products, then I would get a single statement that says insert into product. It would list the columns we're going to insert into, and then it would say values, and then it would have the values listed for each of the 100 products underneath it. We also do a topological sort in here. So we insert things in the correct order, and we have some logic to propagate values back. So if you are using store-generated keys, we need to get those values and propagate them to child items. And then, of course, we can also break up into multiple batches when it makes sense. So that could be sometimes we need to do that to do value propagation for store-generated values. And then sometimes the batch just gets too big and it can't all be included as one single statement. And so in those cases, we will sensibly break things up into batches. And there's also some knobs and switches you can turn to configure the batch size that makes sense for your application. What was the question, sorry?
You said the category you're sending is the one query, right? So can you do the entity framework thing we can do with the odd range, right? There is a method.
I'm going to take the question offline afterwards just because I'm not quite getting it from what you're saying. So come up to me at the end. We can dig into that one. All right, so that was SQL improvements. Let's go ahead and take a look at a feature called shadow state. So shadow state is the concept of having something that's part of my model, but it's not part of my CLR classes. Now, in our Unicorn store, we want to start keeping track of the last time that each item in a user's shopping cart was updated. So this could be the time that the user added the item to their shopping cart, or this could be the time that they increased or decreased the quantity in their shopping cart. Now, the reason we want to do this is we want to run a batch job to say, if something has been sitting in a user's shopping cart for a year and they haven't touched it, then we're going to go ahead and just clean it out of their shopping cart in the database. Chances are after a year, if they return to our store, they probably don't want that thing in their shopping cart. And also, it's going to free up a whole bunch of room in our database from stuff that's just been left around historically. Now, the way I would traditionally do this, if I wanted the stuff kind of managed by Entity Framework, is I would load up the cart item class, and I would go ahead and add a property called last updated. But I don't really want to do that because I don't want the last updated property exposed in my application. I don't want anyone working on the front end to really ever expose that to the user. It's something that's only really intended to be in the database. So rather than adding it to our CLR class, let's add it as a shadow state property. So I'm going to open up our context. In the onModel creating method, I'm going to pull up the configuration for cart item. I'll then drill in and call the property method. Now, this would normally be where I'd pass in a lambda that says which property on the CLR class I'm interested in, but instead I'm going to use a different overload where I give it a type and a name. And this is going to introduce a shadow state property. Now, what I could do here is any configuration that I could do for a property on a CLR class. So I could change the column name, I could change the data type, but I'm actually okay with all the defaults, so we'll just leave it like that. Now, at this point, the property is part of my model, but it doesn't yet exist in the database. Now, I'm operating in a world where my EF model is the source of truth, and it's driving changes to the database. So I'm using Entity Framework migrations to make changes to my model, and then incrementally push those to the database. And obviously, when it's time to deploy, there's probably a DBA in the Unicorn store company, and so I would use my migrations to generate a change script and give those to the DBA. I do just want to point out that Entity Framework is equally valid to be used against an existing database. And so I can have an existing database, and then I can just point some tools at that database and say, give me an Entity Framework model. And there's actually a very early preview of those tools included in the Beta 4 release that's available now. I should say they're very, very early preview. They are lacking a whole bunch of functionality, but we're working on that at the moment. All right, so it's time to add a migration. So folks that are used to migrations, I would normally come to Package Manager console and I would say add migration, and that works in the context of other applications like WPF, WinForms, and the other places you can use Entity Framework. But I'm in the context of ASP.NET 5. And ASP.NET 5 has the concept of commands built into it. So if I go look at my project.json file, you can see I have a command section here. And one of the commands that I've registered is EF. Now, this is another interesting thing in terms of factoring. The PowerShell commands and the command line commands historically were part of the core Entity Framework package, but we've now split them out into Entity Framework.commands. So if you don't want them, pay per play, they're never even referenced in your solution. All right, so the way that I invoke these commands is from the command line. So I've got a command prompt open in my solution directory. DNX is the entry point for ASP.NET 5. If you want to know more about how this stuff works, then Glenn Condren has a deep dive coming up on ASP.NET 5, so that would be a good place to go learn about what DNX is and what ASP.NET 5 is. And then the command that I'm interested in is EF, so I'll just run that. It's obviously not going to do anything yet. So now we have a nice command line experience for using Entity Framework as well. Now at the moment, this command line is specific to ASP.NET 5, but we do want to expand this as an alternative to the PowerShell commands inside Visual Studio. Obviously, if you prefer to work in Visual Studio, you prefer the PowerShell commands, they will still work, and we're going to enable them for ASP.NET 5. But having a command line is a nice alternative as well. All right, so let's actually dig in. We want to use the migration command. We want to add a new migration called last updated. I have two contexts in my solution, so I need to specify which context I want to use. So we want to use the Unicorn Store context. So it's going to look at what's changed in my model since the last migration was created. You might notice just there, commands like this return super quick on top of EF7, and this is just a byproduct of us kind of reinventing the core and getting rid of a lot of the baggage. Stuff is a lot faster as we work around. So let's go look at migrations. We'll see that the last updated migration is now included, and it's just going to add the last updated column to our database. So we'll use the command line to apply that. So instead of add, we're going to call apply. And that will create the last updated column in our database. So it's in our model, it's in our database, but we're currently not doing anything to actually set it. So we go back to our context and scroll down. You'll see that I've overridden save changes. I have a bit of boilerplate code here. Let's just walk over it. So the first thing I'm doing is calling detect changes. Detect changes just scans my objects for any changes that have been made. Normally, this is done as part of save changes, but you can see I actually call save changes after I've run my logic. So I need to go and manually scan for the changes first. I then go and load up any entries from the change tracker where the entry is tracking a cart item and the state of that is either added or modified. And we're then going to loop through them. From the entries, we're going to load up a property, last updated, set the current value on that, set that to UTC now. Now this property could be a shadow state property or it could be a CLR property. It doesn't matter. I can interact with any properties this way. Let's run our application. Let me go ahead and add some items to our cart. Actually, you know what? My wife and I both love coffee, so I'm going to order some matching coffee mugs for us. All right, and if we drop back out here, we'll see that the last updated column is getting included in the insert statement. And you'll also notice when I select the items, the last updated is just included as if it was any other property in my model. But of course, when the item comes into memory, it's not tracked in a property on my entity instance. It's instead kept track of in the change tracker itself as part of Entity Framework. Yep, so the question was, can you actually get access to that property even though it's not on the entity itself? The answer is yes, it's always there in the change tracker, so you can get it that way. And then we are also coming up with some methods where you can actually include it in queries as well. So you would use something like shadow property dot property or whatever, some kind of static method where you say, I'm interested in this property, and you can then filter on it in queries and things like that, or project out to a DTO or something. All right, let's switch gears a bit now. So we've done a bit of looking at the kind of lower level features that enable us to write our application code. Let's swap to a different set of demos. Now, these ones I just want to call out. This is where we transition to using stuff that I built locally. So this isn't something you can download from UGET. This is a preview of features that are mostly currently checked into our working code base and will be available in future previews of Entity Framework. So this is a don't try this at home, at least not yet slide. All right, so let's talk about new platforms. In the context of Unicorn Store, they have a warehouse that's responsible for packaging and shipping the orders that we place. Now, at the moment, that's a manual process. They have some reports they run on the database, they print out a list of orders, and they hand those sheets of paper off to warehouse workers to go fill and ship. Now, obviously, that's a very error-prone system, and we want to replace it with an application. Now, our warehouse is a Windows shop. They have Windows desktops, they have a few Windows tablets, and the majority of the warehouse workers have a Windows phone that the company supplies. So with that information in hand, the best fit for our application is to build a Windows 10 Universal Application Platform app. So let's swap out to Visual Studio. And we'll see that I've made a start on an application, aptly called Unicorn Packer. Now, the way Unicorn Packer is going to work is it's going to talk with a central service and say, give me all of the orders that need to be packed and shipped. And they'll be displayed on the UI. And the user can then select one or more orders and say, I'm going to go and fill these orders. At which point our app will talk back to the central service and say, these orders are in the process of being packed. Now, at this point, we want to take a local copy of the orders because our warehouse is full of large metal things and there's a whole bunch of dead spots for Wi-Fi and cellular network. So we want to take a local copy of the orders so that the warehouse worker can go through and look at those orders while they're in the dead spots. And then once they've finished, they're going to write the shipping label and mark the order as shipped. We're then going to talk back to the central service and say, this order is now shipped. Now, of course, they may be online at the time and we can talk directly to it, or they may be offline and we want to record the fact that we need to later on sync that data back with the central service. Just quickly flicking back to Unicorn Store. If I can get there. We'll see in the controllers here, I actually have an API controller called Shipping Controller that gives me access to all of that information. So it's just part of the main website. I can get the pending orders and a few other actions too. And then if I go back to this Windows 10 UAP app that I've started, I have this wrapper over at the Unicorn Store service, which is going to interact with that service hosted on my local machine. So we're talking to the local host. We have the ability to get all of the pending orders, the ability to mark the fact that the currently logged in user is going to pack a set of orders, and the ability to flag that a particular order is shipped. Now, this service facade that I've got here is returning instances of DTOs. So I've defined some DTOs called order. I track some information like some of the data from the central database, not all of it. And then I've also added properties to track whether this order is shipped, whether the shipping is synced with the central database or not. And then, of course, we also capture the order lines. And in addition to all the usual information, we have a property here to track whether that particular item is packed into the box for this order. And then I've made a start on a context here. So we have an orders context, it inherits from DB context. It exposes a DB set. I'm just reusing those same POCO objects we just looked at. And I've overridden onConfiguring, which is a new method in EF7, which allows me to set up things like the data store I want to target. Now, this is where I want to store local data, and the obvious choice for local data on a device is to use SQLite. So let's go look at our NuGet packages. I'm going to install the entityframework.SQLite package. No prizes for guessing that this is the SQLite provider for Entity Framework. So once we've got that installed in our onConfiguring method, we can say options, use SQLite, and then I just need to pass in a connection string. And then I've already worked out what file I want to store it in, just stored in this variable above. All right, so now we have a DB context hooked up to SQLite on the local device. Let's go and look at some of the screens we have in the application. So choose orders is where the user selects which orders they want to choose. Once they've selected them, we're going to create an instance of our context, and we're going to loop through each of the orders. And so at this point, I'm going to want to go ahead and add the order to the context. I probably also want to add the order lines. So I'm going to use the add range method to add all the lines for this order. Like so, and then once I've added all the orders we're going to work on, I'll call save changes. Now, you don't want to watch me write the rest of this application, so I've already filled it out. So the fill and order form is where I'm walking around the warehouse ticking the boxes. You'll notice as I tick the boxes, this is a data bounds form. And so as I actually change the value of packed on the screen, it's also updating my actual entity instances. And because I'm talking with a local database on disk, there's a very quick operation to save those changes. So actually, every time the user makes a change on the UI, I just quickly flush that change out to the database. So if my app crashes halfway through packing an order, it doesn't matter. All of my data is stored locally. And then when they click the shipped button, we mark the fact that it's shipped in local storage. We then attempt to sync with the central service. And if that succeeds, then we mark it as synced. But if not, we just provide a dialog and we'll deal with syncing it later. All right, let's run the app. Just take a second for it to deploy. So we'll see we have the choose order screen here. It's talking to the central service. I might say I want to pack this one, assign it to myself. So I'm now talking with my local SQLite database, so I can load up the order. I can say that that item is packed in a box. I've put the shipping label on it and handed it off. And I can confirm that item is shipped. And just to prove that that's all talking to the service, if we go back and look at my orders, we have to be working on this one. We can see that it's now marked as shipped in the central database. Now, of course, this is a Windows 10 Universal app, so I can also fire it up in Windows Phone. So let's do that. So it's just going to deploy to the emulator quickly. Now, the nice thing about the emulator is I can actually simulate a network outage. Oops. So we'll go ahead and pick the orders. There's just one left, so I'll assign that to myself. All right, at this point, I'm going to take the device off the network. And just to prove that it's off the network, I'll try and choose the orders again, and you will see that we get an error saying we could not connect. But we can still interact with the local SQLite database. We can walk around and pack the order, mark it as shipped. Of course, we're going to get an error saying I marked it as shipped, but I couldn't sync with the central database. And we can actually see that if we go and look at the order online. This order here, we can see that even though it's marked as shipped on my device, it's still marked as being packed in the central database. But let's go back to the device. We'll bring it back online to the network. Hit the sync button. Come back over to the application, refresh, and we'll see that our order is now marked as shipped. So this is using Entity Framework 7 to target SQLite on a Windows 10 Universal app, which runs on desktop device and tablet. All right, let's keep talking about new platforms for a little bit. So there's another division within Unicorn Store, and that's the graphic design department. And the graphic design department has a little app that they use to track the work orders that they have. So when a user requests some artwork, they enter an item into their work order system, and then the graphic designers have a little app they open up. It shows them the work currently assigned to them, and it allows them to take a series of notes on that work order, status, conversations they've had, and things like that. Now, a graphic design department isn't a Windows department. They run on this operating system here. And their work order system is out of date and it's crashing all the time and they need it replaced. And so they've come to us, the developer section of Unicorn Store, to write a new application for them. Now, we obviously want to reuse all the skill sets we have. So I know how to write .NET code. I know how to use Entity Framework for data access. So one option is to go ahead and write a Windows application for them. And that would work, but the idea of putting a Windows machine on their desk purely for the purpose of running our work order tracking system doesn't really appeal to the graphic designers. It definitely doesn't appeal to the CFO at our company. So what we're going to do is reuse our .NET skills to write an app that's actually going to run on OS X. Now, the tools that I choose here, they're not important. The point here is that anywhere I write .NET code, I can use something like Entity Framework. So I could use Visual Studio Code, and I could target the cross-platform .NET Core. In my situation, I'm actually going to use Mono Develop to target full .NET, so Mono, and I'm going to write a Cocoa front end so it looks and feels like an OS X application. Now, of course, because this is an existing application, it also has an existing database. And because it's running on OS X, it's obviously not SQL Server, so in my case, it's actually Postgres that they've been using. Now, we can't migrate the database to SQL Server because we're going to do an incremental rollout of our new application. We're going to do a pilot on some developers or some graphic designers' machines. So we still need to talk to the existing database at this stage. So you can see here I have a very simple Postgres database. It's called Work, and it has two tables in it called Notes and Work Orders. And of course, because it's an existing database, it has some existing data in it. All right, so I mentioned I'm using MonoDevelop. I'm using the MonoDevelop that's wrapped into Xamarin Studio, but still free to use. And I've made a start on my application. So I've defined some POCO classes that make up the domain model. I obviously have a work order class, and I have a note class here. They look exactly the same as all the other models we've been working with so far today. I've also defined a context here. Inherits from DB context, a DB set for every type in my model. And I've overridden on configuring, and I'm going to go ahead and say use NPG SQL. So I'm going to use the NPG SQL provider to connect to a PostgreSQL database. Now I should point out here, the folks over at NPG SQL have been great. They've been working with us to get an early cut of their provider out. It's actually not available as a NuGet package just yet. If you look at my references, I actually have just a straight reference to npgsql.entityframework7. This is just some binaries that the folks from NPG SQL gave me to demo with. So this is very much a preview of something that's coming. You can't even get this from Nightly Builds at the moment. All right, so you don't want to watch me write Entity Framework code over and over again. So I've already written the code. The main window controller here, when the form fires up, we're going to go ahead and get all of the work orders from the database, only the ones assigned to the current user. When they select a particular work order, we're going to go ahead and load the notes from the database. And then when they add a new note, we'll create an instance of the note class. We'll assign it to the DB set, and we'll call save changes to write it out to the database. Let's go ahead and run. So you can see here we've loaded the data from the database. We happen to be logged in as Jeff. One of his items is to create an ASCII art unicorn. There's a few notes already taken on this. Someone's suggesting that they just steal the EF one. Jeff doesn't think that's a very good idea. So we'll zoom back out. And if we go look at our database and look at the notes, see that as we expect, that data is being persisted using Entity Framework. So that was an example of using EF7 to target a Postgres database on a .NET app running on OS X. All right, let's keep going with new platforms for a minute, actually. So the marketing division at Unicorn Store has decided that they want to take advantage of this craze where people love to have trivial, mindless games on their phone that occupy a large amount of their time. And their idea for an application is to have something called Unicorn Clicker. They're going to flash up a picture of a unicorn. You madly click the unicorn as many times as you can in the allotted time. And it keeps a track of your scores, and it will tell you the most number of clicks that you got of all time. Sounds lame, but this is exactly the kind of thing we stay up to 2 o'clock in the morning playing, right? All right, just give me 1 second to open up something here. All right, so we've heard of this cool product called Xamarin Forms. Xamarin Forms allows us to write applications that target a whole bunch of different platforms. It allows us to write .NET code, which is great. That aligns with us. We're going to stick on OS X for the moment. Obviously, Xamarin Studio also runs on Windows as well. So I have a Unicorn Clicker app here. You'll see a very familiar looking model folder here. It has a game, which represents the actual game that the user is playing. We have a context. There's an Entity Framework context. And then we have a whole bunch of application code here. So if I go and look at the code behind the game page, when we finish the game, we create an instance of the game object. We add it to the DB set, and we call save changes. When we look at the history of our scores, we use a link query using Entity Framework to go and take the top 5 scores of all time. We happen to be measuring those in clicks per second, and then we bind those to the form. So let's go run this. We'll see that my startup project at the moment is set to iOS, so we're going to fire up the iOS simulator. Unicorn Clicker is going to load in a sec. Here's our not-so-subtle advertising to visit the Unicorn Store. Or we can go play a game. See if I can beat what I got at build. I got 35 at build, so not quite. Cool. All right, so now that game is stored in my local data, and if I go look at the scores, I can see data coming back using Entity Framework running .NET code on an iOS device. You can clap for that if you want to. Come on, that's good. All right, so I would just want to show another demo here. Now, this probably would have fit better in with the set of features I was demoing at the start. This is kind of I'm just using EF to develop my application type. But this is something you can't do, at least the way I'm going to demo it, with the currently available beta 4 bits. Now, I just want to say the reason you can't do this with the beta 4 bits is because I'm going to demo it using ASP.NET 5. And the components for unit testing, integration, and Visual Studio for ASP.NET 5 are not currently available on NuGet, though they will be soon. You could take the same demo and you could do it in, say, a WPF or a WinForms application, and it would work just fine with the beta 4 bits of EF7. All right, so you'll remember in our web application that we had a shipping controller, and this was responsible for returning the data to our universal application. And one of the things it does is return the pending orders from the database. So this is all the orders that are marked, in our case, as placed, which means they're ready to be packed up and shipped out. We want to write a unit test to make sure that this controller only ever returns the orders in that state, just so we don't accidentally break it in the future. So I've got a unit test project here, and I've made a start on implementing a get pending orders test. Now you'll see I'm creating an instance of the Unicorn store context. I'm adding some test data to it, and then calling save changes to save that data out. Now the problem at the moment is that Unicorn store context targets a real database. And so that database might have existing data in it. I don't really want to blow it away because it has all the data I've just been testing through the UI. So what I really want to do is be able to redirect this instance of Unicorn store in my test to connect to a different database. So to do that, we're going to go to our Unicorn store context. We're going to add in a constructor. And in this constructor, we're going to take something called a DB context options. And we're going to use the generic one that's strongly typed to our context. And so this is saying, when I create an instance of this context, I'm going to give you all the options, like the database that you should connect to and everything. Now, dependency injection in ASP.NET 5 works fine with this. That's actually how DI works. You set up all your connection strings and everything in startup.cs, and then it can either pass it into this constructor, or if you don't expose this constructor, we can kind of sneak it in the back end of your context when we create it. Now, all I want to do is go ahead and pass that to a base constructor. And so dependency injection in ASP.NET 5 is going to continue passing in the options that connect to SQL Server. Instead of sneaking it in the backdoor, it's now going to pass it in through this constructor. And then we can do something different in our tests. So the way we create options is we create a DB context options builder. I don't have to do it strongly typed, but I'm going to type it to our context. The builder is then that same type that I used in my onConfiguring methods on my other context before. So I get methods like use SQL Server, but in my case, I'm going to say use in memory store. And I'm going to set persist equal to true, which just means that the data in my in-memory store is going to be persistent between different instances of the context that I create with these options. And then to get the options, I can just get them from the builder itself, like so. All right, so we're going to take these options and we'll actually pass it into the context instead. So now instead of creating this data and sending it out to a SQL Server database, it's just going to stick it in our in-memory store. We'll do the same thing down here. You'll notice for my actual test, I'm not using the same context that I inserted the data to. In the real world, my controller is going to run using a fresh, clean instance of the context. So I want to do the same thing in my test. That's not what I want. So we're going to create a new instance of our shipping controller. Our shipping controller takes in a context, so we'll pass that in. And then we'll just call the, not index, the pending orders method on that. And that's going to query the in-memory store. Now you'll notice out of this whole list of orders, there's only one of them here marked as placed. So the pending orders method should filter out all of these other orders. And to check that that's the case, we'll just make sure that the count returned from the result is literally just one order, like so. All right, let's open up Test Explorer. There's our test, and we'll run it. All right, now test passes. So this is a nice way. This was very difficult to do in EF6. Yeah, you can clap. This was very difficult to do in EF6. You really couldn't swap out an in-memory store. The best option you really had was to do a whole bunch of mocking at the top layer Now, the problem with mocking a context is it doesn't really behave like a context. It behaves like whatever logic you put in your mocks. And so this will actually give you proper entity framework behavior, things such as you can actually call include now. And so when you mock a context, basically a whole object graph is sitting there in memory. But in this case, the whole object graph is sitting in the in-memory store. The context only has the actual data you ask for. So if I query for orders, I don't get the shipping details unless I actually ask the context to include those for me. All right, we got a couple of spare minutes. I'm running a couple of minutes ahead, so let's throw in another demo while we're here. This wasn't one I was planning to show, but we've got a few minutes, so let's go off script and hope everything works. So I mentioned that Beta 4 included an early preview of the reverse engineer tools. Now, historically, reverse engineer only worked as a designer or a graphical UI in Visual Studio, which is good. We plan to add that for EF7 as well. It's not there at the moment. But something that's really nice is the ability to run things from a command line, because that gives you the ability to automate them as part of your build process. Or if you have a really complicated process where you want to reverse engineer for a subset of the tables, then rather than having to click all of the appropriate buttons in the designer all the time, you can just write a script that says, you know, reverse engineer the model from this database, include these classes, maybe exclude columns that match a certain pattern, you know, however you decide to approach it. So let's create a new project. I'm going to create just a console app to show this one. We'll target .NET 4.5.1 will work. Currently for EF7, the kind of lowest framework that we target is 4.5.1 for the relational components. Let's add some NuGet packages. So I'm just going to make sure I'm targeting the Beta 4 packages. I have a cache of those on my machine just because Wi-Fi is hideous at conferences usually. All right, so let's go ahead and add a NuGet package. And I'm going to search for the commands package. We'll see entity framework.commands. I'll install that. You will notice now I talk about everything being much more factored. Yeah, that's kind of reflected in the fact that installing EF used to install about 2 NuGet packages. When you install it now, you end up with significantly more than 2 NuGet packages. And that's just because everything, us and the .NET framework and everything, is kind of broken up into these smaller components. So you have more packages in your app, but you actually have less assemblies and less code that you're referencing. All right, so because I have the commands installed, and this is a console app, not an ASP.NET 5 app, I have things like add migration is now available in Package Manager console. So a new command that's available is reverse engineer. Now, there will be a whole bunch of switches on here. There'll be switches to let me select which tables I want to reverse engineer and things like that. But for the moment, it's kind of an all or nothing, at least in Beta 4. We've made some progress in our working dev branch. So the one thing I can pass in here is a connection string. And everybody knows how to write SQL Server connection strings off the top of their head, don't they? Especially when you target local DB, which we made it in past versions. When you install Visual Studio, it was really hard to remember. Am I targeting V11, which would be V11.0 here, but we made that way easier now by making it this thing. You can all remember that, right? Let's just point it at the Unicorn Store database that we created before. And then we're going to use integrated security. Yes, I write connection strings quite a bit. So we'll kick that off. Hopefully I got everything right. No, I didn't. Oh. SQL, OpenDB. Oh no. Let me open. I did actually try this. Let's just double check we got the right. We can skip the demo if it doesn't work. This is what I get for going off script. Yeah, it's there. All right, let's try it one more time and see if it works. There we go. Now, you might notice there, reverse engineer used to be a very slow process in EF6. Where we would have taken 10 to 15 seconds to reverse engineer even a simple model, what you saw there is the whole thing completed in just a couple of seconds. And of course, the things we get back are just simple POCO objects like we would expect, just properties and navigation properties. We initialize your collections for you. We also create a context for you. So we have DB sets for all the types in our model. On configuring, I can obviously move this connection string somewhere else. And we will do a better job of putting the connection string in the right spot in the past. And then just to prove this works, let's create an instance of our context. And then we'll loop through each of the products. And let's run it and make sure we actually get data back from the database. And we do. So there's reverse engineer working in beta form. I was almost regretting the off-script thing there. All right. Let's just talk about a few places you can go to next. So if you want to come up and talk with me, I'm going to hang around after the session, but you can also find me between 12 and 2 in the expo hall. Look for the big cloud platform section. Underneath that, there's actually a web development booth sitting under developer tools. If you want to learn more about EF7 itself, then aka.ms/aboutEF7 is a good place to go. You'll find a whole bunch of content like tutorials on how to get started, some documents about what EF7 is all about, and other such things. Hang on, I'll take your question in one sec. If you want to get involved in the project, then head over to our GitHub repo. And I'm actually going to show you the GitHub repo just because I want to show you that it's more than just code. So I'm just going to load it up on here. It won't be a sec. I am connected to a network. Maybe. All right, forget it. I am connected to a network, but whatever. OK. On our GitHub repo, we have things like design meeting notes and other stuff. So you can actually get involved not just when we write the code and not just when we publish nightly builds, but you can actually get involved in the design process of EF7 before we even write a line of code. Each week we have a design meeting, we publish notes from it, and that's where we discuss what we're going to be building and how we're going to be building it. And then finally, folks always are after the source code for demos. So if you go to my GitHub account, and you can get these slides online afterwards and grab the URLs from them. But under my GitHub repo, you'll find the Unicorn Store repository. And in there, you'll find the completed source code for the demo. And actually, you'll also find the starting point source code, which I had on my machine before we got going. So if you want to do the same demos for folks at your organization or user group or whatever, you can actually grab the source code and run through the same demos that I just showed here. Obviously, the ones that don't use nightly builds. And then finally, before we wrap up, I do just want to encourage you to please fill out session evaluations. I know everybody says this and everybody just skips over the slide, but session evaluations do actually really help us do a better job of presenting. I would ask, especially if there's something you think could have been done better in this session or other sessions, that you just quickly jot down a comment to say what you would have liked to have seen in the session. We've got a couple of minutes, but I'm actually just going to wrap up and folks can come up and ask me if you have questions. I'm going to hang around for the next 30 minutes or so, and then if you want to find me later, I'll be in the expo hall. So thank you very much for your time. Enjoy the rest of the conference.